Hello everyone, welcome back to my channel. Today we will solve the frog jump problem. This problem comes under the hard section in Leetcode. This also belongs to the jump series. Now let's look at the problem statement. A frog is crossing a river and the river is divided into some number of units. And at each unit there may or may not exist a stone. The frog can jump on a stone, but it must not jump into the water. Given a list of stone positions in sorted ascending order, determine if the frog can cross the river by landing on the last stone. Initially, the frog is on the first stone and assumes the first jump must be of 1 unit. If the last jump was k unit, then the next jump must be either k minus 1, k or k plus 1 unit. The frog can only jump in the forward direction. Now, let's understand the problem by solving one test case first. Let's consider the test case given over here. I have taken the test case given in Leetcode. In this given array, each value represents the stone position. It is also given the array is sorted in ascending order. Hence, from the last value, we can get the length of the river. And here I have drawn the river in units also, like this, where S mentions the stone position and empty means water. It is also mentioned in the question that initial position is 0 and the first jump unit is 1. Now let's see how to proceed. As we are allowed to take steps only to stones, we can explore each value in the given array. And for each stone, we can check the following two things. 1. If we are able to reach a stone, and what will be the next jump values from this stone? Once we have the jump values from a stone, we can explore further and check if the next position is water or stone. If it is stone, then we have to repeat the same process. If it is water, then we don't have to do anything. In this way, we will check if we can reach the last stone position or not. And we will return the answer accordingly. So let's start exploring the process. Initial position is 0 and the jump value which I can take is 1. That means this stone value we are able to reach and the next jump value from this position is 1. Now if we can take jump of 1 unit, then what will be the next position? The next position is also 1. Now 1 is present over here, that means 1 is stone. Then we will explore further. We can reach till stone 1 position and then we will check what is the next jump values that we can take from index 1 or stone position 1. Now it is given if the previous jump value is j, then we are allowed to take j minus 1, j and j plus 1. This will be the next step, jump values. So from 1, we have taken a jump value of 1 to reach index 1, we are able to take of jump 0, 1 and 2. But there is no meaning to take a jump of 0 value. So we can ignore it directly. Similarly, from 1, if we take a value of 1 jump, then we will go to value index 2. But index 2 is water. Then we don't have to do anything. Then proceed further. And from 1, if we can take a jump of 2 units, we will be going to index 3. Index 3 is a stone. So we can explore further from index 3. Now if we are at index 3 and we are taking a jump of 2 to reach index 3, what will be the next jump values from index 3? It will be 1, 2 and 3. Now we are at index stone position 3. Now stone position 3, we are allowed to take 1 unit of jump. This is water, nothing to do. From 3 with jump 2, we are able to reach index 5. 5 is stone So we will be putting this mapping. From 5, we can go to, we can take jump values of 1, 2, 3 because we are taking 2 jumps to reach index 5 or stone position 5. Similarly, from 3 with step 3, we can go to index 6. Yes, 6 is a stone. So we are allowed to put the mapping. As we have taken 3 jumps, so the value of the next jump will be 2, 3, and 4. Now we are coming to this value, this position, which is stone 5. Stone position 5, from 5, if we are taking a jump of 1, then the next position will be stone 6. From stone 6, um, from 5, we have taken a jump unit, a jump value of 1 step, and then we have reached stone position 6. So, what will be the next set of jump values that we can take for this option? Will be 0, 1, and 2. There is no point to take 0 jump, but for 1, we can add 1 over here with 1 jump, and also like 2 is already there, so nothing to add over here. Similarly, from 5, if we can take a jump value of 2, then we will be going to position 7, which is water, so nothing to do. From 5, if we take a jump of 3 steps, then we will go to index 8, which is a stone position. So we are allowed to create this mapping. And as a previous jump value is 3, from 5 to reach 8, the next set of jump values that we can take from 8 will be 2, 3, and 4. Right? Now we have explored this. Now we will be proceed further, and we are at index 6, stone 6. From stone 6, if we take one value of jump, that is 7, that is water, so nothing to do. From 6, if we take a jump of value 2, then we will be going to index 8, which is stone. Now we are coming to index 8 or stone 8 with 2 jump. Then the possible next jump from index or stone 8 will be 1, and 2 and 3 is being already added, so nothing to add for anything else. From 6, if we can take a jump value of 3, we will be going to 9, which is water, so nothing to do. Similarly, from 6, if we take a jump value of 4, we will be going to index 10, which is again water, so nothing to do. Next, start exploring further. So from index 8, if we take a jump value of 1, index will be 9, which is water, so nothing to do. From 8, if we take 2 jump, index will be 10, which is water, so nothing to do. Similarly, for 3 jump and 4, okay, 3 jump also, we will be going to 11, so nothing to do. But from 8, if we take a jump value of 8, we will be going to index 12 or stone 12, which is stone. So we are allowed to create the mapping. So from 8, we are taking a jump of value 4, and we are coming to in stone 12. So what will be the next set of jump values from stone 12, which will be 3, 4, and 5. Now we have explored stone 8. Next is stone 12. So we are able to reach index 12 or stone 12. From stone 12, if we take a jump value of 3, we will be going to 15, which is water, so nothing to do. If we take a jump of 4, we will be going to index 16, which is water, again nothing to do. But from 12, if we take a jump of 15, 5, we are going to 17, right? So we have already reached the last stone position. Whenever we are just we can update it the way we are updating for the previous values also, or we can return true directly from here. So that is the process how we will be solving this question. Now we'll look for a test case where we are not able to reach the last stone position. So let's look at the second test case. Now let's look at the second test case where it is not possible to reach the last stone. This is also given in Leetcode. Similar to the last problem statement, I have drawn this river with wherever with the stone positions and water positions, and this is a given array. Let's start exploring. So, as always, the initial position is stone 0, and we are having we are allowed to jump 1 unit. So we are at index 0. So the next position that we will be going to is stone 1. Now stone 1, we are reaching by jump value of 1. That means the next set of jump values that we are allowed to take from stone 1 will be 0, 1 and 2. There is no meaning to take 0 jump, so cancelling this one. Now we are at index 1, which is stone 1. From stone 1, if we take jump of 1 unit, we will be going to stone index 2, which is stone. So we are allowed to create this map. And next set of jump values from stone 2 will be 0, 1 and 2. Similarly, cancelling 0 because there is no meaning to take 0 jump. From 1, if we take 2 step jump values, then we will be going to index 3, which is stone 3, which is stone again. So we are allowed to create this mapping. As the jump value is 2, then we will be allowed to take 1, 2, 3 as next jumps from stone 3. Now we have completed exploring all the possible jump values from stone 1. Now next go further, and we are at stone 2. From stone 2, if we take a jump of 1, we will be going to index 3, which is stone. Then from as the jump value is 1, the next set of jump values will be 0, 1 and 2. And so 1, 2 is already there in the map, then nothing to add new. From 2, if we take 2 jumps, we will be going to index 4, which is having a stone. So we are allowed to create this mapping. And with jump value as 2, the next set of jump value will be 1, 2 and 3 from index 4. As we have completed exploring stone 2, let's start exploring stone 3. From stone 3, if we go to take one jump, we will be going to index 4, which is having stone, and with for 1 we are allowed to take 0, 1 and 2 jumps. 1 and 2 is already being inserted and there is no point to insert 0, so nothing to do. Then from 3, if we take 2 jumps, the index will be 5, which is water, so nothing to do. From 3, if we take 3 jumps, we will be going to index 6, which is water, so again nothing to do. As we have completed all the possible jumps from index 3, let's start exploring stone 4. From 4, if we take 1 jump, we will be going to index 5, which is water, so nothing to do. Similarly, from 4 to, if we take 2 jumps, we will be going to index 6, which is water, so again nothing to do. From 4, if we take 3 jumps, again we are going to index 7, which is water, so nothing to do. And we have completed this all possible jumps which are allowed to take from stone 4. Now we will be moving further, and now we have the stone 8 to explore. See, from stone 8, every time what we are checking, whether we are able to reach current stone, and then what will be the next set of jump values that we are allowed to take from that particular stone, right? But stone 8, we are not allowed to reach till stone 8, so nothing to do, right? Even if it is stone, but we don't have any mapping here, right? So we can't proceed further from stone 8. Similarly, from stone 9, even if it's stone, but we can't even reach from starting positions to stone 9, so nothing to do. Similarly, 11 also is not present in this mapping, so even if it's stone, from start position, we are not allowed to reach the last stone. So in this case, we will be returning false. Now let's see how we can solve this in code. We will start from index 0 and we will keep on exploring each value in the given array. For each stone, we will check if it is reachable from start index or not. And if it is reachable, then we will be exploring the next set of jump values. Now to check if it is reachable or not and to explore or store the next set of jump values, we will be using unordered map dataset, where the key will be the stone position which are reachable from start. So any stone which is not reachable from start index, we will not keep that stone in the unordered map. And the value will be the set of all possible jump values which we are allowed to take from that stone position. Once we reach the last stone position and found it is reachable from start, we will be returning true. Now let's code it. Now let's code it. So first we will be taking the size of the given stones array, and as we discussed, we will be using some unordered map of data type key value. Key type is integer to store all the stones, and value again will be unordered set of type integer again, and let's name it as jumps. So in jumps mapping, we will be storing all the stone values which is of integer type, and again in the unordered set we will be storing the each possible set of next set of jump that we are allowed to take from any stone. Let's take current index I, and as we mentioned, like in jumps we will be storing the stones value which is given in our given array, right? So this is one way to identify whether the next position that we are exploring with some jump value from the current stone, whether that is a water position or a stone position, because if it is present in the jumps mapping, then that means it's a stone, or else it is it's some water position, right? So first we will be pushing every stone value in this mapping. So in jumps of the stones value of I, we will be creating an unordered set which is empty set, because till now we haven't explored any next possible set of jump values that we can take from current some index, right? But it's all also given like 0th stone will have jump value of 1. So that's why for 0th stone we are pushing jump value of 1. Now we have to keep on exploring each element in the given array. So this will be my current stone. My current stone is this value, right? And we have to explore all the possible jump value that we can get from this current stone. So for right, so current stone is the ith index from the stones. Now if we are able to reach this current stone from start index, then we will be going inside this for loop, because then we are able to populate this jumps mapping with the next possible set of jump values from current stone. So now we have to explore all of the jump values. So next we will be going to some position which will be this current stone index plus the jump value, right? Now we have to check whether the next position is water or stone. Now one way to check is jumps dot find position not equals to jumps dot end. That means it is stone. If it is, then we have to populate the next position with possible set of jump values. So we have to put inside jumps of position, we have to insert this jump minus 1. Similarly, we have to insert other values like jump plus 1 and jump. So let's put these values, right? One thing we have to check, jump minus 1 if it is greater than 0, because I already mentioned, like if it is, there is no meaning to take a 0 jump, right? And there is one possibility like here that can happen, the 0 jump, right? So that's why we added this kind of check, like if only the jump minus 1 is greater than 0, then only push that thing, and it's a set, so no duplicate value will get inserted. And when we are exploring this position, we have to check whether this position is already the last position. If this is stones of n minus 1, if it is last position, then we have to return true. And if we are not returning true, then we have to return false. So just look at this code now to understand a bit more. Suppose we are at current stone. So we are exploring one by one stone, right? And if the last stone index is reachable from current stone, that will be within the loop only. Sometime I'm exploring that index. So once I am able to reach the last stone, then I'm returning true. But look at the second test case where from 8, we are not able to reach 8 in stone 8, right? So in the mapping, we will be having value key value 8 present because it's stone. But the value set, unordered set with respect to stone 8 will be empty. So here, this part won't get executed for the stone 8 in the second test case, right? Similarly for 9, we won't be able to execute this part because similarly the stone 9 will have empty value set. Similarly for 11, it is stone but we won't get anything. So this part will not get returned because we are able to reach stone 11 as we are exploring all the stones in the given array, but it is not reachable from the starting index. So this path will be followed and we will be returning false in the second test case. Now let's run this code and let's see if we need to fix some part of it or it is working fine. I think this should work fine, but let's check. Okay, this is working fine. Let's submit this code now. Okay, this is accepted. Now we need to look for the space complexity and time complexity, right? So space complexity talking about, okay, first let's talk about the time complexity. So for time complexity, we are exploring n number of times. So n number of stones given. So we are exploring n number of times. And for each stone at max, we are exploring 3 jump values, right? So this for loop and again this for loop. So this for loop will be always of order of constant because 3 jump values will be there at max, right? Or even if it's not 3, some constant value also, because if it is possible to get suppose position 6 is stone 6 is having we are able to reach position or stone 6 from stone 3 and stone 5, then at max 6. In similar way, we will be having those many options. But at max, it's like within the, it will lie within the range of this array only. So the time complexity will be order of n. And also the space complexity will be order of n only because here we are using this mapping. And we are using unordered set and unordered map, so searching time won't get affected because so that will be always constant time. Thank you for watching. Stay tuned for my further videos to come up. Thanks.